Hello. Um, I'm going to work through these problems that will most likely be on the midterm. I'll walk you through like my thought process and what I'm thinking while seeing these problems. All right, so these ones are just simplifying expressions. So we're going to be dealing with some exponent rules here. I see an exponent on the outside of these parentheses, which makes me think that and since there's only multiplication in here, I know that I'm going to have to distribute. Those are really thick. It's really thick. I'm going to have to distribute this exponent to everything that's in here. So this is going to look like 3 cubed, which is 27, r to the negative 2 cubed. And so when we have an exponent to an exponent, we multiply them, so we get r to the negative 6. And then t cubed is just t cubed. Times here we're going to have the same thing, the negative 2 squared, which is a positive 4. We have an r cubed squared, so we multiply those exponents to get r to the 6th, and then a w squared to get w squared. Now we could do some more simplifying here. We have 27 and 4. Those can just get multiplied. This r to the negative 6 and r to the 6, we're going to be able to multiply and add those exponents. However, this t and w, they don't have any like brethren, I guess, in the rest of the equation, so they're just going to get stuck onto the back. 27 times 4 is 98, maybe? I don't know. Let me see. 8, 9, 10, 108. Oops. 108. And then r to the negative 6 times r to the 6. When we're multiplying two things that have the same base, so r to the negative 6 times r to the 6, we just add their exponents. So negative 6 plus 6, which equals r to the 0. And one of our exponent rules was that anything to the 0 is just 1. So this goes to 1 times 1. And then our t cubed and w squared are just going to get tacked on the edge here. Notice multiplying by 1 doesn't really do anything, so this would be our final answer for that one. All right. Now, when we have like something rational, so like a fraction kind of, raised to an exponent, we could either distribute this exponent first above, like to the top and to the bottom, or we could try and simplify this fraction first. I'm going to try and simplify the fraction first because I think I see something I can do. When we have y over y squared, one of our exponent rules was that we subtract. So this is the same as y to the first to the 1 minus 2 power, which is just y to the negative 1. So we can rewrite this as 4x cubed y to the negative 1, and then we keep that to the negative 2 power there. 4 to the negative 2 power, we're going to, again, distribute this negative 2. 4 to the negative 2 power is the same as 1 over 4 to the second power. That was, again, one of those exponent rules. So this can be 1 over 16. So we get 1 over 16, x cubed to the negative 2 power. You multiply those exponents, since you have an exponent to an exponent, to get x to the negative 6. Y to the negative 1 to the negative second. Multiply those again. A negative times a negative, though, so that's going to be a positive, so y squared. And this is, we can rewrite this as y squared over 16x to the negative 6, or to the positive 6. This x goes in the denominator. We know that because it has this, because it's to a negative power. All right. Combine the polynomials, simplify if possible. So here we're just collecting like terms. This minus sign is going to have to distribute, though, to everything inside this polynomial. So I'll rewrite this as 4x squared minus 5 plus 3x minus 4x minus 9, and then plus x squared. So now I know we have these x squareds, we have these x terms, and then we also have like constants. That's a weird way to, well, so I'll connect our 4x squared and x squared to be 5x squared. I'll connect our 3x and the negative 4x to be negative x. And then this negative 5 and negative 9 can come together to be negative 14. And so that would be the answer there. Expand the polynomial via multiplication. So because we have addition in here, we can't just bring this 2 across like that. We're gonna have to rewrite this at gonna have to rewrite this as 2x plus 3 times 2x plus 3. Okay, and from here we can FOIL it. That's first, outer, inner, last. So first we get 4x squared because we multiply the coefficients as well as the variable to get 4x squared. Then we do outer 2x and 3 to get 6x. Notice the x comes along for the ride. 3 times 2x is going to be the same as 2x times 3, which was 6x. And then we have last, which is 3 times 3, which is 9. So we get 4x squared plus 12x plus 9. Notice these combine into a 12x and not like a 12x squared, because we're not multiplying them, we're just adding them. All right. Here we are going to factor these expressions. Nice. Okay. I notice here 12, 10, and 12, they're all even. So I know at least they're going to have a common factor of 2. And so I'm going to pull that out first. 2 times 6x squared minus 5x minus 6. Okay. And here we're going to have to use our factoring method where we multiply the 6, or the a in ax squared plus bx plus c, the a times the c. So 6 times 6 is 36. So we're looking for factors that multiply to negative 36 and add to negative 5. So let's see, we have 1, 36, 2, 18, 3, and 12, 6 and 6, 4 and 9. 4 and 9 looks right to me. Since this is negative, we're going to have a negative 9 on the bigger number. So we'd get 2 times, and then rewrite this as 6x squared minus 9x plus 4x minus 6. And let's see what we can factor by grouping here. These have a common factor of 3x. So we get, we'll leave this 2 on the outside, 3x times 2x minus 3, plus we could pull a 2 out of here to get 2 times 2x minus 3. And we could factor out this 2x minus 3 to get 2 times 3x plus 2 times 2x minus 3. And so since we're just factoring them and not actually like solving for x, this is our final answer here. All right. Let's see what we can do here. We have 2x cubed y squared minus 18x cubed. I'm noticing this y squared is by itself. There's no y squared here. So it doesn't seem like there's going to be much we can do with that, but I do notice 2 and 18 are both even, and we also have an x cubed and an x cubed here, so I can at least take out a 2x cubed from both of these. Let's try that. We get y squared minus 9. Okay, and now this y squared has come into play. we have y squared and 9, which is the same as 3 squared. And so this is a difference of two perfect squares. So we can rewrite this as 2x cubed times y minus 3 times y plus 3. And so that comes from, this part comes from the fact that a squared minus b squared equals a minus b times a plus b. All right. That was problem set 1, I guess. Let's look at problem set 2. Find the restricted values of z for the following rational expression. All right, so restricted values, that means like not allowed. And so for restricted values in a rational expression, that's going to be when our denominator equals 0. So let's look at when this thing equals 0. So we have z squared minus 4z minus 12 equals 0. This looks like something we'll be able to factor. Factors of 12 are 1 and 12, 2 and 6. 2 and 6 looks right. I know the 6 is going to be negative since this middle term is negative. So let's rewrite the, we don't actually have to rewrite anything here. We could just go straight to z plus 2 times z minus 6. And we could go straight there because we have a 1 in front of here rather than a not 1. And so now we're using the zero product property that says if two numbers multiply to be 0, at least one of them has to be 0. So we're going to set each of these equal to 0 individually. So z plus 2 equals 0. Subtract 2 from both sides. We get z equals negative 2. Add 6 to both sides here. We get z equals 6. So our restricted values are going to be both 2 and 6 because that's where our denominator is equal to 0. Subtract the rational expressions and simplify. All right. So to subtract them, we are going to have to get a common denominator. And so to get a common denominator, I'm going to multiply each of these fractions by whatever they're missing. So like this one has a y minus 1, but it's missing a 2y. This one has a 2y, but it's missing a y minus 1. So I'm going to multiply by y minus 1 over y minus 1 here. And things should combine. So we get 5 times y minus 1 over 2y times y minus 1 minus y plus 2 times 2y over 2y times y minus 1. So now we have the same denominator, and so we can just write this as 5 times y minus 1 minus y plus 2 times 2y all over 2y times y minus 1. Since it wants us to simplify, that's just going to look like distributing this 5 and then distributing this 2y. And I actually like the denominator like that, so I'm going to leave it. So we get 5y, 5 times y, minus 5 times negative 1, minus 2y times y is 2y squared, and then minus 2y times 2 is 4y, all over 2y times y minus 1. Now we have a common or like terms here, so I'm going to combine those to get negative 5 minus 2y squared. 5y minus 4y is just a y. And then all of this is again over 2y minus, or times y minus 1. Oh gosh. There we go. And so that's our final answer. Solve the linear equation. This always makes me happy when I see linear equation because I know the worst that's going to happen is I'm going to distribute and combine like terms. So let's do that. I'm going to distribute this 3, I'm going to distribute this 4, and let's see what that gets us. We get 15 minus 3x. Let's distribute this negative while we're at it, actually. Minus 2x minus 2 equals 5 plus 4x minus 28. All right, we have some x's here, some constants here, and we also have some constants on this side. So let's combine them. This 15 and this negative 2 becomes 13. Negative 3x minus 2x is going to be the same as negative 5x. And then this equals 5 minus 28 is a negative 23. And then plus 4x. Let's add 5x to both sides. Let's add 23 to both sides. 13 plus 23 is 36. 5x plus 4x is 9x. Divide by 9, we get x equals 4, because 36 divided by 9 is 4. And that's it. Solve the inequality. All right. Express your answer in interval notation and on the number line. Sure thing. So to solve the inequality, we're going to have to get x by itself. X is kind of wrapped up in some division here, so I don't want to deal with that before I've dealt with the 2 on the side. And so what I do to one side, I've got to do to all sides. So like what we have with equal signs normally, except now it's like on both sides, I guess, which is very enjoyable. So we get negative x minus 1 over 3 less than 6. And now we can multiply by 3 everywhere. So times 3 there, times 3 there, times 3 there. Negative 2 times 3 is negative 6, which is less than, these 3's cancel, negative x minus 1, which is less than 18. We have a negative here. We could distribute it. I'm just going to divide by a negative 1 everywhere. Well, we'll distribute it. We'll see where that gets us. Negative 6 is less than negative x plus 1, less than 18. Let's subtract 1 from everywhere. Get negative 7 is less than negative x is less than 17. And now we have a negative x. We're going to have to divide by a negative 1 on everywhere. However, when we divide by a negative, we've got to flip the signs. All right. And so now, looking here, I see x is between negative 17 and 7. Although, since this is a greater than or equal to sign, I know that it can be 7, but it cannot be 17. Let me rewrite this. So our smallest number is negative 17. What the fudge? Negative 17, and it can't be negative 17, so that means we get parentheses there. And then our biggest value is 7, and it can be 7, so we get brackets there. On a number line, this would look like, let's see if here's 0. I won't put a dot. There's 0. Skip a few. Skip a few here. Here's negative 17. Here's 7. I get a closed dot over 7. Closed dot because less than or equal to, or greater than or equal to. And then open circle over 17. And where are we going to shade in? We're going to shade in between, because this is telling us that x is between these two values. Solve the quadratic equation using the quadratic formula. Okay, that's very good news. the quadratic formula. This is the quadratic formula right there. Of course, you probably have the call and response song memorized, engraved on your heart, I would assume. If not, maybe now's a good time, I guess. Let's see. So A in this case is 1, B is -10, and C is 11. And so let's plug in. -b, -10 is 10, plus or minus square root of b squared, 100, minus 4 times a, which is 1, times c, which is 11, all over 2a, which is 2. 100 minus 4 times 11. Well, 4 times 11 is 44. And 100 minus 44 is 56. So we get x equals 10 plus or minus the square root of 56 all over 2. Square root of 56 can probably be simplified because 4 goes into it, let me think, 10, 14 times. So let's see, we get x equals 10 plus or minus the square root of 2 square root 14 over 2. And I'll show how I got that. So the way we simplify radicals is by finding the biggest perfect square that goes into them. 56, just from having been around 56 a lot in my lifetime, I know that 56 is divisible by 4. And so 56 is the same thing as 4 times 14, which is the same thing as the square root of 4 times the square root of 14. But we know that the square root of 4 is 2, so we get 2 square root of 14. So the process is find the biggest square that goes into it, split it up like this, and then the perfect square will become square rooted and on the outside, and whatever is left will stay on the inside. So there's a little bit more we can simplify here because 10 is divisible by 2, 2 is divisible by 2, and we're dividing by 2. So we get x equals 5 plus or minus the square root of 14. All right. So that was problem set 1 as well as problem set 2. I have just a few more things we can do. And so this will be systems of equations. All right, so let's say we have the system 2x plus 3y equals 12 and 4x minus 3y equals 6. This, totally not chosen beforehand, beautiful system of equations looks perfect for elimination. Why does it look perfect for elimination? Because we have a positive 3y here and a negative 3y here. And so I know when we add those, 3y minus 3y is 0. And so that's going to cancel out nicely and lead us to solving this problem very quickly and efficiently. So let's add these two things. Add these two things, 2x plus 4x, 6x, of course, 0. And then keep our equal sign, 12 plus 6 is 18. So now, to solve for x, just divide by 6, x equals 3. Of course, the solution to a system of equation is always either, it's going to look like either some kind of point, x1 comma y1. It's either going to look like infinite solutions. My class always wrote it out kind of like that. Or no solutions. My class always wrote it out like that. Although I think you guys are writing, let's see, this would be consistent, dependent, and then this is inconsistent. And then if you have a solution, this means it is consistent and independent. All right, well, anyways, so we got one of our coordinates, 3, and to find the other one, we're just going to take this 3, and we're going to plug it into one of our other equations. I'll plug it into this this first one here. So we get, let's see, we get 2 times 3 plus 3y equals 12. 2 times 3, of course, is 6, plus 3y equals 12. Let's subtract 6 from both sides. We get 3y equals 6 divided by 3, y equals 2. So we have x equals 3, y equals 2, so our solution to this would be 3, 2. All right, so that's elimination. Let's try another system of equations. Y equals 2x minus 1, and 3x plus y equals 11. All right, now this system of equations, this system of equations, I'll label this. I won't label it. It doesn't matter. This system of equations is also very splendid and well to work with. I know that just by looking at it. What I'm noticing here is that one of our variables has already been solved for. This is really great to see. I love this. Y equals 2x minus 1. Since it's already been solved for, we can just take this and plug 2x minus 1 in everywhere we see a y into our other equation. I only see one y, which makes this even easier. This is great. Let's see. So plugging this in, we get 3x plus 2x minus 1 equals 11. And now we just combine like terms and solve. 3x plus 2x, 5x. This minus 1 equals 11. Plus 1 to both sides, we get 5x equals 12. Bummer, we're going to get a fraction. That's unfortunate. I wish I planned ahead, but it's okay. We're going to divide by 5 on both sides to get x equals 12 over 5. It's not so bad of a fraction. Now we need to find the other coordinate point. So to do that, we're just going to plug in 12 over 5, where we see an x, into this equation. So, whoa, it erased. Okay, that was awesome. Let's see, so we're going to plug in 12 over 5 here. And so we get y equals 2 times 12 over 5 minus 1. So we're going to 2 times 12 over 5 is 24 over 5 minus 1, which 24 over 5 minus 1 is the same thing as 24 over 5 minus 5 over 5, because 5 over 5 is just 1. And now we can subtract straight across. So we get y equals 24 minus 5 is 19, and then we keep the denominator, 19 over 5. So our coordinate point would be 12 over 5, comma 19 over 5. Wonderful. And so this is a consistent and independent system, and same is true for this one up here. I'm not going to write it, but it is true. All right, and so let's look at a word problem, because you most certainly will have a word problem system of equation on your midterm. I would bet. I would assume. I'm thinking so. Allison told me. No, she didn't. I lied. But if she did, I would tell you guys. But she didn't. But she will. Okay, let's see. A movie, a movie theater sold 50 tickets. Okay, let's see. And made $400. I wish I wrote this out beforehand. Adult tickets cost $10, and student tickets cost $6. How many of each type of ticket was sold? Well, that's a great question. Let's find out. So let's call adult tickets X and student tickets Y. All right. So since they sold 50 tickets total, that means that all of the adult tickets plus all of the student tickets totaled up to 50. So we get X plus Y equals 50 as our first equation. All right, and they made $400 from these tickets. Well, how would we figure out how much money you made from selling 4 tickets? Well, or 4 adult tickets. You would do 4 times 10, of course. Just now, instead of knowing that you sold 4, we know that you sold X of them. So we get 10X plus 6Y equals 400. And again, that comes from finding how much money we made from the adult tickets, the 10X, plus how much money we made from the student tickets, the 6Y, and we know that equals 400 total. Okay, and setting them up is probably the hardest part, unless you're really struggling with systems of equations, in which case the whole thing is probably really hard. Yeah, well, I hope that's not the case. But if it is, rewatch this 50,000 times and it might not be the case any longer. Probably. So now let's solve this. Let's solve this thing. How are we going to solve it? Well, let's do substitution. I'm a substitution fan. So I'm going to rewrite this equation as y equals 50 minus x. And I got that by subtracting x from both sides. Okay, now I'm going to take this equation and I'm going to plug in 50 minus x where I see a y. I only see one y. Just going to make this easy. So 10x plus 6 times 50 minus x equals 400. All right. 10x plus, let's distribute the 6. 6 times 50 is 300, I think. And 6 times negative x is negative 6x equals 400. We have some like terms here, this 10x and this negative 6x. Let's combine those to get 4x plus 300 equals 400. Let's subtract 300 from both sides to get 4x equals 100. And divide by 4 on both sides. X equals, let's check our calculators here, 25. Wonderful. Okay, so now I know x equals 25. How the heck am I going to figure out what y equals? Well, we did it 3 times already, or at least this is the 3rd time we're doing it, so I hope you have an idea by now. We're just going to plug it into our original equation. Either one works, but one of them looks a lot easier to me than the other, and it is this one. But we even solved it for y over here, so I'm actually going to use this one. So we plug in 25 here, we get y equals 50 minus 25. 50 minus 25. I can do that. Y equals 25. Wow, that's awesome. They're the same thing. That's so cool. And so now let's write this as a point. 25, 25. Although it makes more sense interpreted. Well, let's actually answer the question it asked. It asked how many of each type of ticket was sold. 25 adult tickets and 25 student tickets were sold. Okay, I've got just one more problem. Just one more problem for you guys. And this one's like a bonus, just thrown on top for you, for free. Free for you. I'm getting paid for this, but it is free for you. Let's see. This is going to be linear inequalities. I'm just going to do one of these. Okay, let's see. We get, okay, 4x minus 2y is greater than 6, and negative 3x plus y is less than or equal to 9. All right. First, I'm going to put these into slope-intercept form because that's how I like to graph my equations. I refuse to graph something outside of slope-intercept form. I'm picky like that. So, what are we going to do? I'm going to add 2y to both sides. And while I'm at it, oh fudge, I keep hitting the wrong one. And while I'm at it, I'm going to subtract this 6 from both sides as well. So we're going to get 4x minus 6 is greater than 2y. Divide by 2 everywhere, we get 2x minus 3 is greater than y. Okay, awesome. Here, I'm going to add 3x to both sides. Oh no, I lost my Duolingo streak. Damn it. Okay, well, we get y is less than or equal to 3x plus 9. Okay, both of our equations are now in slope-intercept form. Let's get graphing. Oh, plus 9. Okay, it's fine. Okay, here's a graph. Well, it's gonna be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 12. All right, awesome. No, don't undo. Okay, let's graph this. We'll graph this first one first, and then we'll graph the second one second. I think that makes sense. Okay, let's actually start with number 2. Um, okay, slope-intercept form. That's great. Why is it great? Because we have our intercept and our slope. Our intercept slope form. So, our intercept is 9. And what does that mean? That means we intersect the y-axis at 9. So let's count 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. I hope you were following along there. It's that point right there. And our slope is 3. Our slope is 3. What does that mean? It means we go up 3, right 1, or we can go down 3, left 1. I'm going to do one of those. 1, 2, 3, 1. I bet. There we go. All right, and let's see. This sign here tells us that we should have a solid line and not some non-solid line. So let's do that. Boom. Okay. Coolio. I'm going to wait to shade. No, you know what? I'll shade now. I can even put in some cool colors here. So let's see. Y less than 3x plus 9. Okay. Okay. So there's, okay. There's a few ways you can do this. And by few, I mean 2. You can use a test point, which is a good way of doing this. And so that's what we're going to do. Let's use 0, 0 and plug in 0 for each of these. We get 0 less than or equal to 3 times 0 plus 9. 0 less than 3 times 0 is 0. 0 less than or equal to 9. Yup. So we would shade in the area that includes 0, 0. The way I like to do these, well, I don't want to be confusing. Let's just stick with the test point. No! Okay. Oof, that was scary. That was scary. I hope it didn't sound like I lost my cool, because I totally didn't. All right, let's graph this next one. 2x minus 3 greater than y. Okay, so again, we're in slope-intercept form. We have a slope, we have an intercept. Our intercept is negative 3. So let's go to negative 3. 1, 2, 3. I was counting down. All right, and our slope is 2. That means up. Nope. That means up to right 1 or down to left 1. So let's go. Boom, boom, boom. Okay. Let's see. These lines look parallel, but trust me, that's because I'm very bad at drawing, and it has nothing to do with them actually being parallel or not. Okay. So let's pick another test point. I'm gonna pick 0, 0. That might come as a surprise. It probably shouldn't. Let's see. Let's plug in 0, 0. 2 times 0 minus 3 is greater than 0. Is this true? 2 times 0 is 0. So negative 3 is greater than 0. Is that true? No. No, it is not. So let's shade in that area that does not have 0, 0 in it. And that's going to be below our line. Oh my gosh. Adrian made a classic mistake. What was his classic mistake? And look at the friggin' sign. This sign does not have an or equals to, which means that I need a freaking dashed line here. Do not make this mistake on your exam, or else you'll fail. Probably not. It's probably not enough to make you fail, but still, these are easy points you should be getting. So So make sure to double check your work like I was doing. Surely. Anyways, where was I? Oh yeah, 0, 0 is false. So let's shade in the place that doesn't have 0, 0, which is going to be all of it. Okay, that's nice. There we go. Okay. Our equation says and means two things. Two things must be true. So we need red and blue. So I'm gonna get rid of everything that's just red. Nothing is just blue, and so, okay, this is gonna be really hard to get rid of it all. So just pretend like I got rid of it all. Yeah. Nothing seems just blue. It might be because I'm a bad drawer. I don't think it is. Eventually there would probably be some just blue, but it's not on this graph, so it doesn't matter. Well, yeah. Anyways, this is the final image you would need. Okay. Well, I hope you gained something from this. Hopefully. All right.